Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at our Chapter 6 test review. This is found on page 353 of our textbook. We're going to just go ahead and jump right in. So in exercises 1 and 2, MN represents that mid-segment. So what would be the value of x? So we're going to look at the first one. Since MN is a mid-segment, it is half of 12, so x has to be 6. Over here, the mid-segment is MN, but you notice that x is on the other side of that, so that means JM is equal to ML, so x has to be equal to 9. Next up, for number 3, find the indicated measure, identify the theorem that you use. Because this is the perpendicular, we're showing the perpendicular bisector, we're going to use the perpendicular bisector theorem. And in order to do that, we can set these two expressions equal to one another. So 3x plus 8 is equal to 7x minus 4. Moving our x's to the same side and moving our constants to the same side. We're going to end up with 4 is equal to 4x, which means x is equal to 2. Oh no, just kidding. 3. Once we have x is equal to 3, then we can find the indicated measures of ST. ST is here, so I'm just going to plug in that 3. 7 times 3 minus 4. 21 minus 4 is 17. Up here, we also have a bisector theorem, but this one's the angle bisector theorem. So that means both of these angles would be equal to one another. So that means these segments can be equal. So 6x plus 2 is equal to 9x minus 13. We're going to start by moving our variables to the same side, move our constants to the same side as well. We're going to get 15 equals 3x, so x must be 5. Then we can plug it in to find out what wy is equal to. So 6x plus 2. 6 times 5 is 30, plus 2 is 32. Onward to number 5, indicated measure here. This is where we would want to use the in-center theorem. Because what we're seeing here is your angle bisectors making that in-center. Looking at BW, we know that it's also the same thing as WC, so BW is equal to 20. Number 6, copy and complete the statement using less than, greater than, or equal to. If we're looking at AB and comparing that to CB, AB is across from 20 degrees while CB is across from 18, and since 20 is greater than 18, AB has to be greater than CB. Number 7, the measure of angle 1 will be less than the measure of angle 2, since angle 1 is across from 11, and since 11 is less than 13. And then picking up on number 8, the measure of angle MNP is across from 12, and NPM is across from 14, so MNP should be less than NPM. This is the part that might have taken you a while because we're going to find the coordinates of the 3 things listed here: circumcenter, orthocenter, and centroid. So we got to make sure we understand the differences between those. The orthocenter, it actually comes out to be very simple at this one. The first thing we want to do is we want to take time to plot our points. So I'm going to go ahead and plot our A at 0, -2, our B, which is 4, -2. So each of these is a separate graph. If you wanted to do them all in the same one, that just kind of gets tricky to see. And then C is at 0, 6. Okay, so I'm going to try my best here to make some straight lines happen. You probably can do a much better job than me on paper, just kind of tough on a tablet. Once we have these graphed, we will start with the circumcenter, which is your perpendicular bisectors. All right, so starting with circumcenter, we want to see perpendicular bisectors, which means we need to find your midpoints and then your perpendicular slopes. So if we look at segment AB, Segment AB is 1, 2, 3, 4 across, so the mid segment is going to be here. I'm going to label that M to show that. And then because AB is a slope of 0, the perpendicular slope would be undefined. Then I looked at AC because I probably can use AC and that'll overlap with the line I just drew. AC is 8 units long, so that means my 4, 1, 2, 3, 4 would be my mid segment. And then since this slope is undefined, going straight up and down, the opposite perpendicular slope would be here. So now that I have that, it is crossing over at approximately 2, 2. Up next, we're going to try our orthocenter. And remember, orthocenter uses altitudes. Now, the nice thing with this one is because it is a right triangle, that means your orthocenter is going to be on the right triangle. One thing I do here is I look for perpendicular slopes, and it has to cross through the opposite vertex. So if you look at AB, AB has a slope of 0. So AB slope is 0. So your perpendicular slope is going to have to be undefined, which if you look at this, it has to go through the opposite vertex, which is point C. The only way to do that is if I follow it on the line from point A up through point C. Then I can maybe try that same thing with line AC. Line AC's slope right now is undefined, and my perpendicular slope then would need to be 0 through the opposite point, which would be B. So the only way I can do that again is starting on this line, which is still CA line or AC line, and going through point B, which would end up here, which makes my two overlapping points at 0, -2. Okay, the one that took the longest here was the centroid. So when I use the centroid, remember I'm trying to use the medians, and I'm connecting median through the opposite vertex. So if I maybe want to start at AB, I know that my midpoint is here, so I need to connect it to the C up here. And I know that AC's midpoint was 1, 2, 3, 4 right here. If you want to label these M's, just so you know these are midpoints, you can. But CA is opposite of B. And then the last one, CB, you just have to find the distance between C and B. So we would take that distance formula and do our x2 minus x1 squared plus y2 minus y1 squared. So I'm going to do 0 minus 4 squared plus 6 minus -2 squared. -4 squared is going to be 16, and then 6 minus -2 is 8. 8 squared is 64. And then if I take 16 plus 64, I'm going to get 80. I don't know why I'm doing the distance formula here. Probably should have done the midpoint formula. Silly me. 4 plus 0 divided by 2, and -2 plus 6 divided by 2. 4 divided by 2 is 2, and then -2 plus 6 is another 4. 4 divided by 2 is 2. So 2, 2 is that midpoint. My line's a little off there, and then I'm going to the opposite vertex. This one is not perfect on a line, so I would say this is like 1 1/3, 2/3 for your centroid. Okay. Going on, we have number 10. It says write an indirect proof. So I'm going to type here on the screen just so it can go a little bit quicker. Of the corollary to the base angles theorem. If triangle PQR is an equilateral triangle, then it is equiangular. So first we want to assume the false statement. Assume triangle PQR is equilateral but not equiangular. So the measure of angle P doesn't equal to the measure of angle Q, and Q doesn't equal an angle Q, angle Q doesn't equal to the measure of angle R. And angle P doesn't equal to the measure of angle R. So we just covered the basis that none of these angles are matching. But by the contrapositive of the base angles theorem, if the measure of angle P doesn't equal to the measure of angle Q, then QR can't equal PR. And then you can continue saying that for the rest of the statements. If Q doesn't equal R, then PR can't equal PQ. And if P doesn't equal R, then QR can't equal PQ. These contradict the original equilateral statement. So triangle PQR is equilateral, then it has to be equiangular. Okay. Up next, number 11, triangle DEF is a right triangle with area A. Use the area for triangle DEF to write an expression for the area of triangle GH. So what we know is that G is the midpoint of ED because it's showing that separation, and so is H. H is the midpoint of EF. So that means GEH is equal to half of DEF. Well, to try and find the area of DEF, we would use 1/2 base times height. But then you have to find half of that. So really, area A would be, GEH's would be 1/4 of the area of DEF, because 1/2 times 1/2 would give you that 1/4. Number 12, this one is a great one to practice. It'll definitely be showing up on your test tomorrow. We want to draw a picture. First, two hikers start at a visitor center. So I'm going to start here with visitor center. And the first hike's 4 miles due west. Remember, never eat soggy waffles. So first hiker goes to the west 4 miles. The second hiker goes 4 miles east. Both of them turn and go 1.8 more miles. But the first one is turning 40 degrees. And the second one is turning 52 degrees. And goes for another 1.8. So we're using the degree comparisons. The supplement of 40, and I might have turned them the wrong way, but same type of deal here. They're going east and west and then either north or south. 140 would be the supplement for the first hiker, and for the second hiker, 52 minus 180 would be 128. So the first hiker is farther, since 140 degrees is greater than 128 degrees. Okay? 13, 14, and 15 all go together, describing the possible lengths of Pine Avenue. Here's Pine Avenue, And notice it making a triangle, so I can do my inequality here. Maybe I start with 7 plus 9 is greater than x, so that means 16 can be greater than x. I can also do 7 plus x has to be greater than 9, so x has to be greater than 2. So I can say between 2 and 16 miles for that one. Okay. For number 14, you ride your bike along the trail that represents the shortest distance from the beach to Main Street. So here's beach, and here is Main Street, so shortest drive would be probably Pine Avenue or Hill Street, either one. But you end up exactly halfway between your house and the movie theater, so what I initially drew here. That perpendicular bisector showing through that half angle. How long is Pine Avenue? And explain. What we can do is use the perpendicular bisector theorem to find out how long Pine Avenue is. And for that one, you would simply have to look at your other two measurements here and kind of go from there. So with that, you're probably going to end up choosing or needing to choose 9 miles, just because whenever you do that, it's going to represent the shortest path from the beach to Main Street. It has to be perpendicular to Main Street, and we ended up at our midpoint between our house and the theater. So your trail has to be the perpendicular bisector between those two things, so that could be the same distance from your house to the movie theater. So that's why we want to choose 9. The last one says a market is the same distance from your house, the movie theater, and the beach. Use that on your chart, copy the map, and locate the market. This is when you want to use the perpendicular bisector to locate the circumcenter. So I already did one perpendicular bisector, but another one could be here, and then your third one can be here, right there. That is going to conclude our test review. Thanks so much for tuning in. Hopefully this helped you, and we will catch you next time.